From the darkness between stars, our galaxy drifts like a glowing island in an endless sea. We call it the Milky Way, a spiral of light so vast that even at the speed of light, it would take 100,000 years to cross. And yet, in the grand scale of the cosmos, it is nothing more than a single ripple on an infinite ocean. Every point of light we see in the night sky, every shimmering blur captured by our telescopes, is not a star, but a city of stars, a galaxy, a collection of billions, sometimes trillions, of suns, gas, dust, and dark matter, all bound together by the invisible hand of gravity. They are the true architecture of the universe, the bones of the cosmos itself. For most of human history, we thought our galaxy was everything. We believed the Milky Way was the entire universe, the grand container of all creation. But the deeper we looked, the more the illusion fell apart. The universe revealed itself to be not one galaxy, but hundreds of billions, scattered across time and space, like islands of light floating in an infinite night. Some are elegant spirals, gracefully turning for billions of years. Others are chaotic and broken, torn apart by cosmic collisions. Some burn with furious star formation. Others are long dead, their stars cold and fading. Each one is a story, a window into a different chapter of cosmic evolution. The images we see today from the Hubble and James Webb Space Telescopes are not just photographs, they are time machines. Each galaxy we capture is seen not as it is, but as it was billions of years ago, when the universe was young and chaotic. The further we look, the further back in time we travel, until we reach the first flickers of light after the Big Bang itself. But behind the beauty lies a question far deeper than physics. What exactly are galaxies? Are they merely the scaffolding of cosmic structure? Or are they something more? A reflection of order emerging from chaos, a glimpse into the universe's desire to organize itself. Because when you stare long enough into those distant lights, the feeling is impossible to ignore. Galaxies do not just exist. They become. They evolve. They collide, merge, dissolve, and reappear. They are alive in ways that no human language can fully describe. Tonight, we are going to journey across that ocean of galaxies, to see the colossal and the delicate, the ancient and the newborn, the serene and the violent. To understand what they are, how they formed, and what they reveal about the story of everything. And somewhere out there, in one of those swirling islands of light, perhaps another civilization is looking back, wondering if they too are alone in the sea of stars. But first, we must go back to the beginning, to the moment humanity first realized that the Milky Way was not the universe, but merely one of its countless shores. For thousands of years, when ancient civilizations looked up at the night sky, they believed they were staring into eternity itself. The Greeks imagined the Milky Way as milk spilled from the breast of a goddess. The Chinese called it the Silver River. To the Maya, it was the road of souls stretching across the heavens. But whatever the name, they all shared the same assumption. This glowing band across the night sky was the universe. Everything. The beginning and the end. For most of human history, no one could imagine otherwise. The stars seemed fixed, unmoving, eternal. Even as telescopes emerged in the 1600s, the truth remained hidden in plain sight. Astronomers like Galileo and Herschel mapped the Milky Way, believing it to be a single, vast collection of stars surrounded by nothingness. The word galaxy itself came from the Greek galaxias, simply the Milky Circle, and for centuries, that was all it meant. Then came the 20th century, and with it, a quiet revolution that would redefine everything. In the 1910s, astronomers using the world's largest telescopes began noticing faint, fuzzy patches of light scattered across the sky. Spiral nebulae, as they called them. Some thought they were gas clouds within our own galaxy. Others suspected something far stranger. But there was no proof, until one man decided to measure the distance. In 1923, a young astronomer named Edwin Hubble pointed the 100-inch Hooker telescope at a spiral nebula in the constellation Andromeda. By identifying a special kind of star, called a Cepheid variable, he could calculate its true brightness and distance. The result was staggering. Andromeda was over 2 million light-years away, far outside the boundaries of the Milky Way. It was not a nebula. It was another galaxy. Overnight, the size of the universe exploded in our minds. The Milky Way was no longer the whole. It was one among billions. Humanity's cosmic address shifted from the center of creation to a small suburb in a vast, expanding metropolis. The universe had structure, order, hierarchy, a tapestry woven from countless galaxies stretching to infinity. Hubble's discovery did not end there. Over the next decade, he measured the light from dozens of galaxies and found that their spectra were redshifted. Their light stretched toward longer wavelengths. That meant they were moving away from us. Every galaxy, in every direction, was receding. The universe was expanding. This single realization shattered the static cosmos of Newton and Einstein's early models. The universe was not a frozen stage. It was alive, dynamic, evolving. For the first time, humanity saw itself not as the center, but as part of a moving whole, a single observer inside a living universe. What began as a fuzzy patch of light became the key to understanding everything. And from that moment on, astronomy was no longer just about stars. It was about time. Each galaxy we observed became a chapter in a story, billions of years long, written in light. But the deeper we looked, the stranger the story became. Some galaxies spun like whirlpools. Others glowed red with dying stars or shone blue with newborn suns. Some collided and tore each other apart. The universe was not a quiet cathedral. It was a storm. To understand its chaos, we would need to look closer. To open the anatomy of a galaxy itself and see what holds it together across the ages. A galaxy is not just a collection of stars. It is an ecosystem, a vast and intricate machine built from gravity, matter, and time. Imagine it as a living organism stretched across hundreds of thousands of light years, each part playing its role in a cosmic symphony. At its heart lies the bulge, a dense sphere of ancient stars orbiting a dark secret, a supermassive black hole, millions or even billions of times the mass of the Sun. Around it spins the galactic disk, a flat spiral of gas, dust, and newborn stars, glowing in hues of blue and white. Surrounding everything is the halo, an invisible sphere of dark matter that outweighs all the stars combined. Without it, the galaxy would tear itself apart. We cannot see it, but we can feel its gravity, shaping every motion, every orbit, every collision. Our Milky Way is one of these majestic spirals, with sweeping arms that curl outward from its center, like ribbons of light. It holds more than 200 billion stars and perhaps 1 trillion planets. Within its clouds of dust, stars are constantly being born and dying, recycling matter into new generations. Every single atom in your body, carbon, oxygen, iron, was forged in such stars, scattered by ancient supernovae, gathered again into the clouds that would one day form our sun. To look at a galaxy, then, is to look at your own origin. And yet, not all galaxies share this graceful form. Some are elliptical, massive, ancient, and red, shaped like glowing eggs. They are the graveyards of the universe, filled with old, dying stars and little gas left to make new ones. Others are irregular, torn apart by gravitational interactions, distorted into chaotic shapes that seem to defy symmetry. These are the scars of cosmic violence, places where galaxies have collided and merged, leaving behind trails of stars like cosmic debris fields. At the core of nearly every galaxy lies a black hole, and though these monsters of gravity are invisible, their influence is unmistakable. They devour gas, stars, even light itself, releasing jets of energy that can span entire galaxies. These colossal engines, known as active galactic nuclei, can outshine all the stars around them combined. They regulate star formation, sculpting the life cycle of the galaxy. Without them, galaxies might grow uncontrollably. With them, the balance is maintained, a strange cosmic equilibrium between creation and destruction. But a galaxy is more than its parts. It is a pattern, a rhythm written into the fabric of space-time. Its stars orbit a common center, its spiral arms move like waves through water, and its clusters form networks connected by invisible bridges of dark matter. No galaxy truly exists alone. They are linked, woven together into the cosmic web, a structure of filaments and voids stretching across the observable universe. In this web, each galaxy is a node in an immense cosmic network, interacting, colliding, and merging across billions of years. The Milky Way itself is not still. It is moving, drawn toward our neighboring giant, the Andromeda Galaxy, at nearly 400 kilometers per second. In about 4 billion years, the two will collide, their shapes shredded by gravity, their stars cast into new orbits. It will be violent and beautiful, a merger that will create a new, larger elliptical galaxy, perhaps called Milky Way. And through it all, our descendants, if any survive, may watch the sky as Andromeda grows brighter each night until it fills the heavens. Galaxies are not static. They are stories written in motion. They are born from chaos, shaped by gravity, sustained by balance, and ultimately consumed by time. To understand their anatomy is to glimpse the blueprint of the universe itself. But the cosmos does not stop at the ordinary. Beyond the familiar spirals and ellipses, there exist galaxies so immense, so violent, and so improbable that they challenge our understanding of physics itself. To see them is to confront the universe's imagination, its ability to create structures that seem almost alive. Among the hundreds of billions of galaxies scattered across the universe, some defy every expectation. They are the outliers, the impossible ones that force us to question what we think we know about how galaxies form, live, and die. The most extraordinary among them are not merely objects of beauty. They are puzzles written in light, anomalies that seem to bend the rules of reality itself. Take IC 1101, for instance, the largest known galaxy ever discovered. It resides more than 1 billion light-years away in the heart of the Hubble 2029 cluster. It stretches more than 6 million light-years across, so vast that if our Milky Way were placed inside it, it would be a barely visible dot. IC 1101 contains an estimated 100 trillion stars and an unimaginable reservoir of dark matter binding it together. Its scale is so great that light takes 60 million years to cross it. Looking at IC 1101 is like looking at a civilization of galaxies condensed into one colossal being. It is the universe's cathedral, silent, ancient, incomprehensible in size. But not all extremes are giants. At the other end of the spectrum lies Segway 1, one of the faintest and smallest galaxies ever detected. Orbiting our Milky Way just 75,000 light-years away, it contains fewer than 1,000 stars, held together by an invisible cocoon of dark matter. In truth, Segway 1 is more dark matter than galaxy, a whisper of starlight wrapped in gravity's ghost. It is proof that the universe does not need light to build structure. Even in near total darkness, galaxies can exist. Then there are galaxies that break the rules of shape itself. Hoag's object is one of them, a perfect ring of stars encircling a golden core, separated by an empty void. Its symmetry is breathtaking, a cosmic mandala suspended in the dark. No one is entirely sure how it formed. Some say it is the result of a collision billions of years ago. Others think it may be the product of rare gravitational resonance. Whatever the cause, it stands as one of the most hauntingly perfect structures in the cosmos, a reminder that even chaos can create order. Not all galaxies are serene. Some are raging furnaces of creation. The Cigar Galaxy, M82, burns with the light of millions of newborn stars, exploding into existence 10 times faster than the Milky Way can manage. Winds of gas and dust blast outward from its core at speeds of 1,000 kilometers per second, forming glowing filaments that stretch for tens of thousands of light-years. M82 is what astronomers call a starburst galaxy, a brief, furious phase of life in which a galaxy consumes itself in the act of creating. In a few 100 million years, it will go quiet again, its gas exhausted, its fire spent. Even in the cosmos, beauty is fleeting. Then there is ESO 137, 1, a galaxy being torn apart as it plunges through the dense plasma of a galaxy cluster. Its spiral arms are unraveling, its gas stripped away, trailing behind it in glowing ribbons of blue light. It is dying in motion, a galaxy sacrificed to gravity and pressure, its remains scattering like petals into the intergalactic medium. Yet, even in death, it creates. The shock waves from its destruction trigger the birth of new stars in its wake, a cosmic paradox where decay becomes renewal. These galaxies, massive, tiny, beautiful, broken, are not exceptions. They are the universe's way of reminding us that perfection was never the goal. From symmetry to chaos, from birth to collapse, they embody every state of existence. And they show us that even at the scale of galaxies, the universe is an artist, sculpting with time and gravity, experimenting with form. But perhaps the most astonishing thing about these extremes is that they are not alone. Every one of the hundreds of billions of galaxies we can see hides its own secret, a quirk of motion, an asymmetry in light, a mystery buried in dust. To truly understand them, we must look not just at their shapes, but at their fates, at what happens when galaxies collide, merge, and rewrite the map of the universe itself. Because in the cosmic scale of time, every galaxy's story ends the same way, with collision. Galaxies are not static monuments. They are dancers in a vast and violent ballet choreographed by gravity itself. Across billions of years, they drift, approach, collide, and merge in a slow-motion catastrophe that gives birth to new worlds while erasing the old. From afar, the universe may appear calm, but on its grandest stage, it is a place of constant motion, where creation and destruction are inseparable. Every collision reshapes the cosmos, turning chaos into beauty and silence into light. When two galaxies meet, they do not crash like solid objects. Instead, their stars pass through one another, separated by immense distances, while their gas and dust clouds collide, compressing under gravity and triggering waves of star formation. whole constellations ignite in the aftermath, like sparks from a cosmic forge. The galaxies stretch and twist, forming long tidal tails of stars that arc into space, glittering bridges between worlds. For hundreds of millions of years, they spiral around each other until gravity wins and they merge, two vast systems becoming one. The old spiral patterns dissolve. The central black holes sink toward one another, eventually uniting in a titanic burst of gravitational waves that ripple across the fabric of space-time. What remains is often a giant elliptical galaxy, smooth and featureless, the final resting form of galactic evolution. This is not a rare event. It is the norm. The night sky is full of galaxies locked in this eternal cycle, merging, consuming, transforming. The antennae galaxies, some 60 million light-years away, show us what this process looks like in real time. Two spiral galaxies colliding, their arms torn and stretched into luminous filaments. In those fiery regions, new stars are being born at a furious rate, thousands every year. It is chaos sculpting creation, destruction giving birth to light. Our own Milky Way is not exempt from this destiny. It has already devoured dozens of smaller dwarf galaxies, their stars now part of our halo. And in about 4 billion years, it will face its greatest encounter, the collision with the Andromeda Galaxy. Right now, Andromeda is a faint smudge in the northern sky, 2.5 million light-years away. But it is moving toward us at more than 400 kilometers per second. In the far future, its spiral arms will grow brighter, filling our night sky with ribbons of light as it approaches. When the two galaxies finally merge, their shapes will distort, their stars scattering into new orbits. If humanity still exists then, they will witness a sky ablaze with beauty beyond imagination. A horizon filled with two galactic cores glowing side by side. It will not be an ending, but a transformation. The Milky Way and Andromeda will become one, a massive elliptical galaxy that astronomers already call Milkomeda. These mergers are not mere accidents. They are the universe's way of recycling itself. Each collision redistributes matter, fuels new generations of stars, and spreads the heavy elements forged in supernovae across space. Without them, the cosmos would grow stagnant. The iron in our blood, the calcium in our bones, the gold in our jewelry, all of it exists because ancient galaxies collided, mixed their stars, and gave birth to the materials of life. Even our solar system carries within it the debris of forgotten mergers. We are literally made of cosmic collisions. Yet for all its violence, the universe balances its fury with elegance. The shapes that emerge from these encounters, the arcs, bridges, and rings, are not chaos, but choreography. Gravity writes them with precision. Every motion, every spiral, every flicker of starlight follows the same simple law. Out of randomness, order emerges. Out of destruction, structure is born. When we look at galaxies colliding, we are not witnessing ruin. We are watching evolution at the grandest scale imaginable. The universe reshaping itself through fire and time. These titanic mergers are the heartbeat of cosmic history, each one a pulse in the life of creation. But to truly grasp the immensity of it all, we must look deeper still, beyond the collisions, beyond the visible, into the faintest light ever captured, where the oldest galaxies wait like fossils of time itself. When the Hubble Space Telescope was launched in 1990, no one could have imagined the transformation it would bring to our understanding of the universe. For the first time, humanity could see beyond the haze of Earth's atmosphere into the true depth of space. Then, in 1995, scientists dared to perform an experiment that many thought was foolish. They pointed Hubble at a small, empty patch of sky, an area no larger than a grain of sand held at arm's length, and left the shutter open for 10 straight days. What came back was not emptiness, but revelation. The image, known as the Hubble Deep Field, showed more than 3,000 galaxies, each one a universe of its own, hidden in what had once appeared to be pure darkness. That single photograph shattered the last illusion of emptiness. It told us that no matter where we look, the universe is overflowing with galaxies. A decade later, the Hubble Ultra Deep Field pushed even further, revealing 10,000 galaxies in an even smaller region, their light traveling to us from as far back as 13 billion years ago, just a few 100 million years after the Big Bang. The colors in those images are not art, they are time itself. The red galaxies are ancient, their light stretched by cosmic expansion. The blue ones are young, still forming stars at breakneck speed. Together they form a portrait of the universe growing up, a cosmic family album spanning billions of years. But even Hubble had its limits. Beyond a certain point, light becomes too faint, too redshifted to detect. That boundary remained unbroken until the launch of the James Webb Space Telescope. When Webb's first deep field image was released in 2022, it revealed galaxies that existed barely 200 million years after the beginning of time, some of them already massive, structured, and bright. It was as if we had opened a door and found the universe older than expected. The cosmic dawn was supposed to be simple, filled with small, primitive galaxies slowly taking shape. Instead, we found giants, mature and complex, shining in defiance of every model of formation. Some of those galaxies, like JD's GS Z13-0 and Sears 93316, sit at redshifts so extreme that their light left them more than 13.5 billion years ago, when the universe was less than 3% of its current age. The light we see today began its journey long before Earth existed, before the Milky Way had even formed. When you look at those faint smudges, you are looking across the entire history of everything that has ever been. In those images, the galaxies are tiny and fragile, just faint specks of light surrounded by darkness. But they are the seeds of everything that would follow. The spirals, the giants, the collisions, and ultimately, us. The heavy elements in our bodies were born in those early generations of stars, then scattered and reforged countless times in the great cosmic cycle. The universe we inhabit is built from their ashes. The deepest images ever taken are more than scientific achievements. They are philosophical revelations. They show us that the universe is not static, but constantly becoming, unfolding, like an endless story written in light. Every pixel in a deep field image is a portal through time, each one a whisper from a galaxy that may no longer exist. And yet, for all we can see, the universe remains mostly invisible. 95% of it is made of something we cannot detect directly. Dark matter and dark energy, hidden forces that shape the cosmos while remaining beyond our grasp. To understand what lies beneath those shimmering lights, we must now peer into the darkness itself, to see the hidden web that binds the galaxies together. Because if the galaxies are the jewels of the universe, then dark matter is the thread that holds the necklace in place. The deeper we look into the universe, the clearer it becomes that what we can see is only a fraction of what truly exists. The galaxies, the spirals, the ellipticals, the glowing clusters of light, are just the luminous tips of an invisible iceberg. Beneath and between them lies a vast, unseen structure made not of stars, but of something we do not yet understand. We call it dark matter. It neither emits nor absorbs light, yet it sculpts the cosmos, dictating the formation and motion of every galaxy that has ever existed. Without it, the universe as we know it could not hold itself together. The discovery began with a mystery. In the 1930s, astronomer Fritz Zwicky observed that galaxies in the Coma cluster were moving far too fast to be bound by the gravity of their visible stars alone. Decades later, Vera Rubin confirmed the same effect within spiral galaxies themselves. Their outer stars were orbiting at the same speed as their inner ones, defying Newton's laws unless something unseen was providing extra mass. The answer was invisible. An unknown form of matter, outweighing normal matter 5-to-1, silently holding everything in place. Today, dark matter is thought to form enormous halos around galaxies, cosmic cocoons of gravity that cradle and protect the luminous structures within. It acts as scaffolding for the universe, guiding gas and dust into the filaments and clusters that make up the cosmic web. This web is the grand design of everything, a vast network of threads stretching across hundreds of millions of light years, connecting galaxies like neurons in a cosmic brain. Between the filaments lie enormous voids, regions of near-total emptiness, each spanning hundreds of millions of light years, the silent spaces between the songs of creation. And yet, even dark matter is not the end of the mystery. In the late 1990s, observations of distant supernovae revealed something even more shocking. The universe is not just expanding, it is accelerating. Some unknown force, stronger than gravity, is driving galaxies apart faster and faster with every passing moment. Scientists named it dark energy, though the name hides more than it explains. It is not energy in the way we understand it. It is a pressure built into the fabric of space itself, an invisible wind blowing the cosmos ever outward. Together, dark matter and dark energy make up 95% of everything that exists. The stars, planets, and galaxies, the parts we can see, are just the remaining 5%, the cosmic afterthought. To grasp this truth is to confront a kind of cosmic vertigo. The universe is not a collection of visible things, but a symphony of the unseen. Light is only the melody. The harmony lies in the invisible notes that hold it together. The galaxies are like embers floating in a vast, transparent sea, whose depth we cannot yet measure. Scientists have tried to detect dark matter directly, in underground detectors buried deep within, mountains, in particle accelerators, in cosmic ray observatories. But so far, it remains a ghost. We know it is there from the way it bends light and moves galaxies, but it refuses to reveal its face. Perhaps it never will. Perhaps we are the shadows, and it is the light. The more we learn, the more the universe humbles us. For every galaxy we photograph, for every pattern we map, there remains a deeper architecture just out of reach, whispering of laws we have yet to comprehend. But even as we stand on the edge of ignorance, there is beauty in the mystery itself. Because hidden in the darkness, the universe is still creating, still expanding, still dreaming. Yet this dream will not last forever. For galaxies are mortal too. Gravity binds them, time shapes them, but entropy has the final word. As the cosmos continues to expand, the threads of the web will stretch and thin. Galaxies will drift apart, star formation will cease, and the lights will slowly begin to fade. The universe is not eternal. It is an unfolding story with an ending written in silence. Every galaxy, no matter how magnificent, is destined to fade. The forces that built them, the gravity of dark matter, the energy of newborn stars, the collisions that forged new worlds, cannot fight entropy forever. Already, in the deepest regions of the cosmos, we can see galaxies growing quiet, their brilliant blue spirals dim to red, their gas exhausted, their stars burning out one by one. These are the red and dead galaxies, ancient ellipticals that no longer create light, only reflect the faint glow of what once was. They are fossils of the universe's golden age, silent witnesses to a time when everything burned brighter. The fate awaiting our own galaxy is no different. In roughly 4 billion years, the Milky Way and the Andromeda Galaxy will collide in a slow, magnificent embrace. Their shapes will distort, their spiral arms will tear apart, and their central black holes will spiral together, releasing gravitational waves that ripple through space-time itself. When the chaos settles, a new elliptical galaxy will emerge, a vast, golden sphere of stars shining faintly in an expanding darkness. It will be a new beginning, but also the beginning of the end. As trillions of years pass, star formation will cease. The remaining stars will age, cool, and die. Red dwarfs will dim into black dwarfs, cold embers in the void. Black holes will dominate for a time, feeding on what remains, until even they begin to evaporate through the slow leak of Hawking radiation. Galaxies will dissolve, their stars drifting into the darkness between clusters, their light stretched beyond visibility by the accelerating expansion of the universe. The great cosmic web will unravel. The galaxies we see tonight will disappear beyond each other's horizons, their light lost forever to the growing void. This is the universe's final act, the heat death, a time when entropy reaches its maximum and motion itself becomes meaningless. There will be no more collisions, no more stars, no more light. The cosmos will become a silent ocean of cold, thin energy, an infinite winter where even memory fades. And yet, within that vision of quiet extinction, there is a strange beauty. Because this ending is not tragedy, it is transformation. The energy that once fueled galaxies will not vanish, it will disperse, diffused across eternity, becoming part of the universe's final breath. For now, we live in the middle of this story. The galaxies still shine, the stars still burn, and somewhere in one quiet corner of one spiral arm, a species of curious primates has begun to understand what it means to exist inside a dying light. We are temporary observers in a fleeting moment of brilliance, a brief window in which the universe can look at itself and know that it is alive. When we gaze through telescopes at the galaxies scattered across the deep sky, we are not just seeing space, we are seeing time, catching the last flickers of ancient fires before they fade forever. The light from some of those galaxies began its journey before Earth existed, before the sun ignited, before the atoms in our bodies were even forged. We are, quite literally, seeing ghosts. And yet, to witness the death of galaxies is also to witness their meaning. They remind us that everything beautiful is transient, that even the most enduring structures in the universe are bound by the same law of impermanence that shapes our own lives. The galaxies will fade, yes, but not before filling the universe with light, with elements, with the raw materials of thought and consciousness. Their deaths are not losses, they are gifts. So as the lights dim and the stars drift apart, one truth remains. The universe, in all its vastness and silence, has already achieved the impossible. Out of darkness, it created light. Out of chaos, it created order. And out of galaxies, it created beings capable of wonder. And so, we return to where we began, with a question not about the galaxies themselves, but about what their existence means. In the grand scale of the cosmos, our Milky Way is a mere grain of dust, and our Sun, an ordinary star among hundreds of billions. Yet within this fleeting spark of cosmic time, something extraordinary has happened. From the atoms forged in dying stars, consciousness has emerged, capable not only of observing the universe, but of feeling awe in its presence. That may be the rarest phenomenon of all. When we look at the night sky, we are not just seeing galaxies scattered across space. We are witnessing a living archive of creation, a time machine that connects our tiny world to the birth of everything. Every photon that reaches our eyes or our telescopes carries a message across billions of years, a memory of formation, collision, transformation. To look at a galaxy is to read a letter from the past, written in the language of light. The galaxies remind us that scale does not define significance. Yes, they are immense beyond comprehension, some spanning millions of light years, others teeming with trillions of stars. But their true power lies in what they reveal about existence itself. That from nothingness, complexity can arise, that beauty can emerge from gravity and chaos, and that meaning can bloom even in a universe indifferent to it. Perhaps this is why we keep searching, building ever greater telescopes, chasing ever fainter light. We are not only mapping the universe, we are mapping ourselves, tracing the lineage of everything that ever was and everything that ever will be. Each new galaxy discovered is another reminder that the universe is not done telling its story. One day, long after the galaxies have faded and the last star has gone dark, this brief moment of awareness will still have mattered. Because the universe, for a time, knew itself, through us, through our questions, through our wonder. That is the quiet miracle hidden behind the light of the galaxies. Not that they exist, but that we were here to see them. So the next time you step outside and look up, remember, you are gazing into eternity, and eternity is gazing back. Until the next question, and the next impossible light in the dark, keep looking up.